All right, so we need to talk about speed and velocity. Last time we were talking about distance and displacement, kind of what they are, whether they're a vector or a scalar unit. And speed and velocity play the same way here. Okay, so speed, we signify that by a small s. It to find your average speed, it's just distance divided by time. Remember, distance is our small d, so we take our distance divided by how much time we took, and that gives us our speed. You can think about this if you drive a car. If you're going, 20 miles an hour, uh, then you are going 20 miles in 1 hour. So 20 miles is your distance, time is 1, so 20 over 1 is 20, but miles is on top for the distance. Below on the bottom of the fraction is hours, so miles per is what that division bar means, hour. That'll tell you what your speed is. Okay, and all that really means is it's a change in your position. Okay, so when we measure speed or velocity, we're just changing our position. Okay, and when you have a speed, you are changing position. I mean, if we think about it, if I move at 5 miles an hour or 5 meters per second, I'm moving 5 meters every second. My position is changing by 5 meters every second. It's a rate of change. Okay, so I'm changing positions with my speed and velocity. It's a scalar unit, just like in distance. We never talk about the direction something's going. When someone asks you how fast were you driving, or the policeman, if you get pulled over, they never say what was your vector, or what was your velocity. They just say, hey, how fast were you going? They don't really care if you're going uphill, downhill, sideways, up, forward, north, south, east, west, but how fast. So just a magnitude is all that matters. Okay. Our velocity is a little different. We signify that as v, and this will be for the rest of the year and forever and ever. We signify it by a v. That is our capital D, which is our displacement. So d meaning a capital D meaning displacement is our average velocity because it's a vector unit. Okay, and we remember our displacement's our final position. X always means position. It's our final position minus our initial position, which is what the I means here, divided by our time. We don't necessarily care about how far we went, but how far are we from where we started. And it is a vector unit. So velocity, you can use negative numbers when you signify, hey, how fast were you going? Oh, I was going negative 10 meters per second. That'll let everybody else know how fast you were moving. Okay. And in physics, we typically use meters per second. We can use any distance and any time. We could use centimeters per year if we were looking at the rate of tectonic plates moving on the Earth. That is an accurate speed that we'd use for those. But in physics, most time we'll use meters per second. It's a very universal unit that we'll use.